Welcome to the proof of the cosine rule. Now here we have a scalene triangle, and what we're going to be doing is to prove the cosine rule using an algebraic method. Here we have triangle ABC, and we label the triangle, and remembering that the opposite side to the angle is given in lowercase, so we have A, B, and C. Now what we're going to do next is a bit of technique to prove really. We're going to drop a perpendicular from B onto the line AC, which will form two right-angled triangles. For simplicity, we will label that intersection D. Now, the distance AC is actually B. So what we're going to do is to divide it into two parts, where AD will call X and DC will be B minus X because of the entire length being B. Now that we have all parts of our triangle, we can now label the height as H. So all of our triangle now is labeled. So let's do a bit of proof itself. Now let's focus on triangle BAD. By Pythagoras' theorem, c squared will be h squared plus x squared. And rearranging the formula will give us h squared equals c squared minus x squared. So that's one identity that we'll keep, and I've highlighted that in red because we're going to use it again. Now let's go on to triangle BDC. Again, using Pythagoras' theorem, we can see now that a squared is equal to h squared plus b minus x all squared. We'll carry on doing the algebra, meaning we'll expand the brackets, and that will give us h squared at b squared minus 2bx plus x squared. Now, from the first work we did on BAD, we had h squared being c squared minus x squared. So we're going to replace that h squared with c squared minus x squared into our new equation, because as we are trying to get is all of the units being A, B's, and C's. So let's do that. So now we have a squared equals c squared minus x squared, which is replacing h squared. Now if you notice, minus x squared add x squared will leave you with nothing. So we're going to do that by simplifying now. So we're going to get rid of the x squared, the two x squares from it. What we have left is a squared equals c squared plus b squared minus 2bx. Now we have a slight problem because we have an x that we need to remove. So we now need to replace this x. So we go back to triangle BAD. Now using the cosine ratio, cosine of A would be x over c because it's adjacent over hypotenuse. Rearranging that formula will give us a nice algebraic expression for x, because x is now going to be c times cosine A. We just write that as c cos A. Now we have a value for x. We're going to put that value of x back into the equation as it were. So x equals c cosine A. We're going to put x equals c cosine A into a squared equals c squared plus b squared minus 2bx. Now by replacing x, we will have the cosine rule. A squared equals c squared plus b squared minus 2bc cosine A, which proves the cosine rule. Thank you for watching. Thanks for watching. Hope you enjoyed that proof. Bye.